Hello. Welcome back to J4K. So the last time I was here in summer, and this time in October, autumn. And so let's start with the topic. So what I would like to talk about today is about Kubernetes, killer use cases for Kubernetes, and also killer use cases for Kubernetes from the perspective of Java. So because this session is short, I will have to start right away with something. I will explain it later, but we have no time. So let's call it J4K CDK. J4K CDK. This is a nice name, actually. So, and what this is Cloud Development Kit, and I'm choosing Java because it's Java for Kubernetes, J4K. And what I can actually easily do, I can say I would like to have a Fargate cluster, and builders create this with, let's say, cluster. And then I have to give a name, it is name, and the cluster name should be J4K. And then I think it is almost enough. So what I could do, I could remember my cluster and do something with it. But for now, it's okay. So let's see whether it works. Maybe. If it is not complete, it should complain. So let's see, Maven clean package. So you see, this is pure Java. And then let's do this first. So what happens now? It creates behind the scenes a configuration file for creation of Kubernetes, and this already see it doesn't work. Why it doesn't work? It says requires build J4K cluster name. What a sec! I forgot something, and then. It should actually be complete. So strange. So wait a sec. So build and deploy. So if this fails, it means there is no cloud formation, and it failed. It says there is a version is required. Of course. You see, I have to read. So it should be environment. I think this is called, and the version. And I have to tell which Kubernetes version, which is somehow important. I picked the latest, and now it should work. So it was actually, there were good news to do this. So I have the Kubernetes version, which is somehow important. And so just do the same. So this build and deploy is basically the same what I did here, clean package. And by the way, what I showed you right now is a part of the CDK from my GitHub account. So I just cloned this. I actually forgot, wait a sec, to show you this. So in parallel, what you can see is there is no clusters on my account. And towards the end of the session, I would like to show you how far we got. Maybe we got complete Kubernetes installation with pure Java and exactly one line of code. This was the idea. And forgot actually to show you this, but we have here Adam Bean, my GitHub account, and this project was AWS CDK plain. It is just a minimalistic cloud development kit for AWS Java project, which I cloned right now. So this is what I used right now. So forgot to show you this. Okay, so this runs behind the scenes. So he asked me whether it should do. So it creates a lot of stuff, the entire infrastructure. You know, the subnets, VPCs, NAT gateways, internet gateways, and everything behind the scenes. So let's go fast. And for me, homework would be to clean everything up. So this cleaning up is harder than provisioning. Okay, this was the first thing. The next thing, another task I would like to show you or share with you. So I will just close that. Is another project, Jakarta, right? Jakarta EE and microprofile. So let's go here with Jakarta EE project. And now call it J4K, JK. Perfect. So just go with that. And J4K, this was actually not so perfect. J4K, JK, okay. And then build this because I need a war. So let's go here. And yeah, I guess this is the problem. Maven clean package. I'm not very lucky today somehow. better. So Java 11, and it doesn't matter a lot. What this is, maybe I'll show you the code. It's just one single resource, JAX-OS resource. And this J4K, JK, this is my Java resource, and this is like JAX-OS. The path is resources, and there is one resource called ping with a little bit of configuration that exposes the ping resource here. So this is what happens here. Okay, so now I go to target, and I would like to open that. So just open this, and this is my war. Okay, nice. Now, why I did it? Because I prepared also something here, and this is called Payara Cloud, which we'll look in a second on it. And what I did, I created my AirHacks Live namespace, which is already here. And what I could do here, I could, in the namespace, I could actually create a new namespace and call the namespace J4K. So where is it? Oh, no. Okay, this is the first namespace, and what I could do and upload applications. So let's reuse this one. So maybe it's better. Deploy immediately, of course. Choose file, and what I need is I need the file. And where was it? Here. Wait a sec. A little bit mess with the files upload, but so do it again. So I would like to deploy this file, go here, open, and upload. So why I'm doing this right now, because it deploys very fast. The problem is the DNS, what I noticed, sometimes it takes a few seconds or even minutes until this URI becomes visible. So now it's deployed, but I would check in I think it's, wait a second, maybe this one. No one cares, I need the slides now. So now, these were two actions, what we have, what I wanted to prepare in order to show you how it works. And what interesting here for the J4K example, that the war is 4K, 4 kilobytes, which will come back to it. Okay, now, okay, come back here. My name is Adam Bean, and I still like Java, as you probably see. So I use Java to create provision Kubernetes on AWS cloud, and I use Java to push a war to Payara cloud, and they are somehow related. Okay, so if you're interested, there's a podcast, maybe interesting, who's very used to know people from the industry. There is my blog, which is a notepad, and some workshops. What's maybe interesting for you, first Monday of the month, if there are any questions left, feel free to file them in the gist, and I answer them. By the way, if you have questions right now, write them to the chat, and the moderator, Cesar, will read them for me. Yeah, exactly, for me. So there's a workshop around about clouds, and now start with the content. So what I would like to talk with you, so for my observations, the last 2-3 years are the following. So we have private clouds, public clouds, and somehow hybrid clouds, right? So the following observation. Private clouds, there's no such a thing like a private cloud. What I mean by that, usually you will have to create your own private cloud. What I don't mean here by private cloud, that you get AWS Outpost or Azure Stack or to your data center. You're running basically an Amazon or Azure cloud in your data center. What I mean by that, usually you will have to build your own cloud. And what you will use, plain Kubernetes, which is not very common, or something like Rancher or OpenShift, which are Kubernetes flavors. And this makes, of course, sense. Why I show you in a second, because with plain Docker containers, with plain containers, you get a lot of issues. So Kubernetes is a good idea to orchestrate the containers. So, and what it means is, what you will get are, is this like a farm, container farm, basically. So now, what it means, container farm. So do another experiment. So I would like to switch to my screencast folder here. I'm here, and now create another project. I have to be careful with naming. And I would like to use a Quarkus, exactly, the Quarkus. And the group ID is AirHacks. And the artifact ID, now call it Quarkus with like Kubernetes. It looks strange, right? So, but name it this way. And nothing. And yes, go ahead with that. And I would like to switch to Quarkus and then just remove, optimize. I don't like the tests here, source test Java. Okay, and so now open this. So what you will find in Quarkus is exactly such a container. So there's a Docker and container, this JVM, and it actually describes what to do to build a Docker container. So let's try this. So I would like to switch to here and come back to here and then say Maven package. So I get a executable jar and then run the container. So and then build the container, sorry. So I building the container. And usually we use our own Docker files, but now it's the container built. And I could also run the container, yeah. Docker run -d -p is faster maybe then. So, and then name, call it Quarkus, strange name. And what was this was the thing. Okay. So Docker PS, and we have the container here and and curl localhost 8080/ping. No ping, it was hello, I think. And I get hello rest easy. So this was the Quarkus deployment in local container. So works fine. The problem, so actually we have such deployments in production without Kubernetes. The problem is of course ports, managing, you know, versioning and load balancing. With that, I will have to create HR proxy, ingress, everything by myself. And so this is what doesn't happen usually in larger companies. Smaller companies still doing that and very successfully. In larger project is too much overhead. So what you can do instead now, let's go here. And I would like to first, I don't need the rest assured, and let's reuse this. So always, yeah, go ahead. And then I would like to use Quarkus Kubernetes. And what I also would like to use, this is nothing first. So, and now I would like just to build Quarkus again. And what you will get, an error. Why? Because I deleted my entire kubectl environment. Otherwise, it will show you some of my credentials. But what I wanted to show you now that all the Kubernetes plumbing is done. And the interesting part is it uses the decorator plugin, so it watches the metadata and creates this YAML on the fly. And so we could actually pick this and deploy it to the, hopefully, in the background, you know, forming EKS Kubernetes cluster. So what you don't see here, hopefully, health, right? So there is no health. So, but if I would just add a health, microprofile health, so where is it? Here. This is Quarkus, I think, was it health? And I don't think it's parent. So let's build it again. Okay, and now watch this. And I would expect to have some health inside with Q. Exactly. So what happened is, you know, it recognized that and added here the health checks. What I could do, add some properties, annotations, you know, to customize the Kubernetes experience. But what you see is already, this is the YAML. The entire deployment is 100 lines of code, which is far more than my Java code actually. And by the way, the Java code looks exactly like the Payara code I showed you. This is exactly the same API, which I really appreciate. So now, what we learned so far. So where are my slides? What we learned so far, I would say, if you are going Kubernetes in private clouds, so I think Kubernetes is a good thing, and I think for private cloud, this is reasonable, or this is the killer use case for Kubernetes, you know, because without Kubernetes, you cannot just maintain the Docker containers by yourself. you know, if you deploy the second container, you already have to think about the pod numbers, right? So, but with Kubernetes, what you get is you get pods, and on the pods you get services, and the services communicate with each other. So I would say, Kubernetes deployments tend to be a little bit monolithic, and what they also tend to be is request, response, or synchronous. So this is my observation. So most of microservices are kind of monolithic applications, which is not a bad thing, just by nature. With a request response, usually, you know, HTTP, JSON communication, sometimes gRPC. On the other hand, the next killer use case for Kubernetes is to deploy with Kubernetes operators, something like Kafka or Postgres. So you get, you know, this is more like almost a virtual environment where you can just add additional resources. What you're building then with Kubernetes in a private cloud, you building something which is already available in public clouds, because public clouds already have, you know, messaging solutions, storage solutions, and so forth. So whereby in public clouds, you don't need necessarily Kubernetes. Why not? Because, you know, all providers, we have Azure Container Instances, right? So you can push a container and it just runs without any YAML, without caring about deployments and services. So on AWS, you have Azure Service Apps or something like this, where it's even, you know, Azure Container Instances are not as sophisticated. And on AWS, you get, for instance, Fargate, where you can push the Docker container, and the Docker container you show already. So this Docker container, what I created right now, could run on Kubernetes, or it could run on ECS Fargate. It could run on Azure Container Instances or Lightsail or whatever you have, right? So what it means is Kubernetes is fully optional in public cloud. So now, if we think a little bit further in public clouds, if you look what the public clouds are doing, is actually all about events. So if you have a data in public clouds, this is usually what you will get in one point of time. So if you changes the data, you get an event and you are reacting to this event, right? And a classic example, S3 bucket. This is the oldest, I think, service on earth. Oldest cloud service, I think, is the S3 bucket. If you upload a file, you can capture or listen to a S3 creation event with AWS Lambda and react to it. So, but there is, you know, you don't need Kubernetes for that. You just deploy a Pojo or a Quarkus app and it will react to this event, right? So I would say public clouds tend to be event-driven. Private clouds tend to be, I would say, a little bit monolithic and request response and synchronous. Public cloud, event-driven, and asynchronous. Now, hybrid clouds, you can actually have both. So what we're actually doing in some projects is we're saying, okay, we can run, you know, the traditional microservice with relational database and a little bit Kafka and microservices or whatever on Kubernetes. But then we can, if something interesting happened, we can generate the event and push the event to the public cloud, event to the public cloud, and use, you know, built-in or cloud-native features like, I don't know, image recognition, text recognition, text-to-speech, machine learning, fraud detection. And there are the killer use cases of the public clouds, which are hard to replicate in-house. So what it means is Kubernetes is more like do it yourself in privately, and in public clouds, Kubernetes is fully optional. So what is cloud native Java now? So I hear a lot cloud native Java. For me, is not necessarily, you know, pick application what you run, you know, for 20 years on premise and just lift and shift it to or rehost to a public cloud provider and say now I'm cloud native. I mean, this always works. So this is why I never got, you know, the idea why application servers are not cloud native, because application servers, I mean, you can run them perfectly in container. There was never an issue. So what I would understand by cloud native is really using the features of the cloud. So using the services which are there. And for this, Kubernetes is not the best choice. Sometimes it could be even worse than the built-in services in the public cloud. Why? Because Kubernetes is an open source project and it has to be integrated afterwards, except of course Google GCP, Google Cloud Platform, or GKE, the Google Kubernetes distribution, which is great. But all the others, they pick the, you know, the open source project, the Kubernetes, and have to integrate into the cloud, which is more effort than, you know, implement something in-house. Okay, so cloud native Java would mean I just using the feature of the cloud. And the next architectural distinction is microservices versus stream processor. So a stream processor would be, you know, a POJO which listens to Kafka Stream, POJO which listens to Kinesis, or a POJO which listens to SQS. And this could be, again, a microprofile Quarkus application or just plain POJO. So containers are fact, you always need them. And who needs Kubernetes? I think, again, killer use cases. If you're building your own cloud, Kubernetes is the killer feature. So vanilla Kubernetes or distribution. So what is a Kubernetes distribution? For instance, OpenShift. So Kubernetes, if you install vanilla Kubernetes, you will need container registry, you will need the ingress controller or the load balancer, and the distributions like OpenShift bring everything for you. So for instance, what I really like is OpenShift. So there's an integrated build. You can run the entire pipeline, which is fully integrated. So it's, I would say, easier. This is, for me, it's like, plain Linux or Ubuntu. Ubuntu is just nicer, but it's still Linux. So OpenShift is as Kubernetes, but nicer, or Rancher. So this is my take. So I would say if you run Kubernetes in a private or on-premise, I would just pick a distribution. I think it does make a lot of sense, to run your own Kubernetes installation, except your own cloud provider. So, and thankfully, Kelsey Hightower has similar opinion. This is this staff developer advocate Google Cloud Platform, and says Kubernetes is a platform for building platforms. It's a better place to start, not the end game. So, so if you're building a cloud platform, start with Kubernetes. The question is, what are the decisions to building a cloud platform and not using an existing one? This is the interesting point. And if you already have Azure or Google Cloud or Google is a little bit different, but Azure or AWS, do you really still have to run Kubernetes? Okay, now this is interesting part. I think the guys from Payara read the tweet 2017, and what they did, they say, okay, the application servers were supposed to be that, but application servers are actually great, and they come with clustering, and the clustering did what in Payara case, very similar or somehow similar to WebLogic. It was like you have like an admin server, and the admin server coordinated, other servers. And they say, okay, we have, the engine is already working. Why not, just doing the same with Kubernetes? And now the application server became an Kubernetes orchestrator. I would say this is a great idea. So it's a complete different take. So what it means is you can deploy an app to Kubernetes without noticing that. So I already did it, before the slides. I pushed a war to Payara Cloud, and hopefully it will work right now. And I think this is enough time, for the DNS. And wait a sec, where is my browser here? And let's see. J4K, this looks good. And this also looks good. And if I go, was resources, I think resources and pink. And, okay, this is Jakarta E9 should be, of course, and microprofile 4. This is an old example, but you see, I managed to deploy that. And this was a fully a new deployment. And they are working now on better monitoring. And by the way, if you're interested, there is an EHEX-FM podcast with with Patrick Duditz from Payara Cloud, and we had some discussion about that. But I really like the approach. They are running, for instance, right now on Azure, and I don't even notice that. And if you go to the logs, view logs, you see, you will exactly. So you see here that so it started in, okay, it was fast. And so I saw somewhere that there, you will notice somewhere that there is Payara micro. So this is what I wanted to show, but it locked too much. So at the beginning it says no Payara micro. So the genius idea is that the Payara micros, the small Payaras, are running on the pods, and they are started and stopped on demand. And you can even add your custom domain to it. So as and they are building, more monitoring. So for me, this is serverless. And what serverless would mean is, so if I push a war, I don't care about the servers, I don't care about Payara, I just fully care about the Jakarta E and microprofile APIs and about the business logic. So this is actually, from my perspective, a really nice idea what you can achieve. So the other idea is with Quarkus, where Quarkus says, okay, this is actually the exact opposite. Instead of now having no crazy Kubernetes operators. We focus, on simplicity, and we provide the smallest possible runtime. And Micronaut, very similar. So Quarkus and Micronaut are similar in this respect, and Helidon as well. And the interesting part is cloud native Java, right? You have the decision with Quarkus whether you would like to run on GraalVM or on JDK. And in the clouds, this is not always, given that the GraalVM will be the best possible, will come with best possible performance and save you money, because it may be that, with GraalVM, the Lambda cold start is a little bit faster, but every additional, invocation is 10% slower, whereby with OpenJDK or standard Java, with standard JVM, this is what I wanted to say, not OpenJDK, JVM, the first call is a little bit slower, but then it optimizes and gets, faster and faster. So, okay, so now let's see what happened here. ECS Elastic Container Service, this was wrong. I need but yeah, I would like to show you this as well. Elastic Kubernetes Service, EKS. And let's see, clusters. No clusters. So the session is too short to show you this. So last time I checked, it was almost half an hour until everything was created. And this is not the fault of Kubernetes. What it takes a long time, the entire networking and the nuts, this NATs. This takes a long time, but it worked well. Actually, this was the single line, and it is enough to create or to form the entire Kubernetes cluster.
So Adam, while we wait, a quick question.
Yeah.
So with so many, Kubernetes distributions and Java distributions and native images in the market, what are your recommendations on, when to use what? Okay,
so what I would recommend, but this, of course, I'm a consultant, just observing from Europe or Germany. I would say OpenShift on premise is the most popular distribution, I would say, and is really convenient and really nice to use from developer perspective. I never had, to admin OpenShift, but I used OpenShift a lot and I like the experience. So in the cloud, I wouldn't use OpenShift, Kubernetes. For instance, this ECS, okay. This was interesting because I wanted to go to Kubernetes service. And now we have the cluster. So the cluster was created. So the cluster is created, and you can already see I am the admin. I am the admin of this account, and I am not allowed, to view the EKS cluster. So if I would go to command line, it would work. The problem is I have to integrate once again, with the Kubernetes permissions, which is a friction. If I would use other service here, like ECS Fargate, for instance, I would be done. But this is a minor issue. From command line, everything is working. The cool story is, with my Quarkus and a kubectl minus fapply, I would be ready to go, and I would deploy the workload to here. So having said that, what I actually wanted to show you was Elastic Container Service, and this was all part of the answer. And this was task definitions, for instance. So if I create here a new task definition, Fargate means serverless. And yeah, and where is create here? Next step. I never use and ask me stuff. So I have to decide the memory and how much CPUs I would like to have, and the container definition. And I would say, if you do it programmatically from the command line interface, it is roughly 30 lines of JSON. And you are done. And if you have to port this, it's not portable, of course, because ECS Fargate is on AWS, but Azure Container Instances is very similar to Fargate. So you could just do the same, and migrate you just to JSON, and it will behave similarly. So I would say distributions, OpenShift or Rancher. OpenShift is great because it is more usable than plain Kubernetes. In public cloud, if you are thinking about cloud native Java, I would try to be serverless. Why? Because serverless is actually the future from business perspective. This is what I think is. Why? Because right now, the managers project sponsors, PMs, or whatever, however you call them, have the unique opportunity, to see how expensive is a single transaction? Because you are paying per invocation. Whereby if you're running, if you would start, you know, the Kubernetes, nothing is started Kubernetes, but I'm already paying for the control plane. So you're paying for the control plane, and then if you will also have to pay for the workloads. Whereby in serverless, what's the difference? It's just the business, is the business difference, is that you are just paying for what you use, and if there is no traffic, no transaction, you pay nothing. So I would say public cloud, go serverless, Azure Functions, AWS Lambdas, but to be productive and to build maintainable applications, it has to be asynchronous and event-driven. What I already saw was crazy projects where, you know, they split a monolith to Lambda functions and no one knew what's going on, so never do that. But if you think this way, like, you know, I have, let's say, a S3 bucket or blob storage on Azure, and someone uploads a file, an event happens, and I'm reacting to events. This is, I would say, this is the future architecture, and I will consider this cloud native Java. What I'm not considering cloud native is now running my old Payara server in a Docker container on ECS. So I think on a YouTube channel 6-7 years ago I already did it, and it's okay. What's the point? It already works, right? And I hope I answered the question. Cesar, is there any other question?
Yeah, so the future is reactive, basically, if I understand correctly.
Yeah, event-driven, and you could use reactive programming to just deal with it. But I mean, reactive and AWS Lambda is just a method, a public Java method. You can call this method whatever you like, and you string as parameter or JSON as parameter, and you are done. I wouldn't call it reactive programming. It's more like CGI from 1995 or servlets. You know, this is a very simple programming model. The problem is if you are not doing the events properly, then no one will know what's going on. This is like, you know, hell on earth, I would say. So yeah,
right. So that was my follow-up. My follow-up was, what's your recommendation for developers to learn or to, you know, get good practice doing reactive programming, because this is you know, it's not an easy way to program.
Yeah, from developers, it is easy if you come from the business perspective. So I would say the main difference between microservices and event-driven architectures is that microservices, if you search for the definition, there are a couple and they're changing a little bit, but if you Martin Fowler is I would say one of the gurus, right? Martin, not Marin. Martin Fowler, microservices. What's going wrong? Microservices. So, and his definition is like, it's a process which exposes HTTP somewhere. Yeah, this is architecture style which exposes HTTP. And then the next question is, do the microservices know each other? And every microservice is a database and hides the database. So the microservices are only allowed to communicate via HTTP. So if you do the event-driven stuff, it's completely opposite. So let's say Kafka, you have Kafka, then the topics are public. The microservices don't know each other, or the stream processors don't know each other. They just listen to Kafka topics and create data to another Kafka topic. So it just happens. And there is no, you know, hidden databases. Everything is, the data is public, and the let's call stream processor are highly decoupled. So in the cloud, it doesn't have to be Kafka. You could use, for instance, AWS Kinesis or Azure Service Bus, which is very, very similar to Kafka, but cheaper, because Kafka has to be managed and runs on Amazon, and pricing, I think SQS or Kinesis could be, you know, in clouds, I say cost-driven development. You know, everything is nice, but it costs money. So in the end, you will have, you know, to justify why your cloud bill is that high. And this is another thing. I would say it's nothing against running boring workloads on premise with Kubernetes, because you will save money. You know, for running just, you know, the same application on the cloud is going to be more expensive than on premise. But if you do it this way, that you know, get the good stuff, the additional features from the cloud, there is a business value. So that you're adding value to your department or to your company. Yeah. So and therefore I would say the event-driven programming is even simpler. You don't need lots of reactive programming, and with the and on microservice also not, because Project Loom is around the corner, and with Project Loom we will able to start a lots of threads very cheaply. Very good. Next question, Cesar.
Actually, we've reached the end of your allotted time, so we want to thank you very much, Adam, for your presentation. We really enjoyed it, and we'll see you hopefully in the next J4K 2022.
Thank you. Who was the nicest moderator so far? Thank you. Bye.
Bye, Adam. Thanks.